My name is Gary Eisman at the University of Helsinki, and I'd like to introduce you to a project that is being hosted at the University of Helsinki and which concerns the presence of dangerous substances around us in our environment, in our communities, and how these will impact first responders. We are, as an industrial society, surrounded by volatile organic compounds. These are substances as a consequence of the technologies we develop and the materials we utilize. And I have a graphic here that shows where these substances arise. And they are widespread. We find them in our homes, to our work sites. They have a wide range of chemical properties. Some of these are harmless. Others can be directly dangerous to us, or in an accident or when mishandled, may constitute a threat to our health or even our lives. First responders often enter rescue events without a full understanding of the chemicals that are present in such a site and what the consequences may be for their health and welfare. The technologies we're developing in this European Union Horizon 2020 program will develop technologies we believe provide to first responders and emergency staff some tools that will be helpful in their safety and security. An example where volatile organic constituents have had catastrophic effects is the Bhopal gas tragedy in Bhopal, India in December 1984, where over 3,500 were killed and more than 500,000 damaged in their health. In this case, a pesticide facility released volatile constituents in the synthesis of a pesticide, and this substance, methyl isocyanate, spread throughout the community. It's an example of technical failure, human carelessness, and bad urban planning. You can see how homes were allowed to build up around this facility, giving very little time once the release occurred for notification and evacuation. Another example is the Mississauga train derailment in 1979, where a derailment of a freight train carrying styrene, toluene, propane, and chlorine erupted into flames in the center of one of the highest population densities in Toronto, just outside of Toronto, Ontario, around midnight. And the concern was naturally for the substances released, styrene and toluene. More troublesome was the thought that the propane and chlorine in the flame would produce phosgene, a chemical warfare agent used in World War I. And would this spread into the community? When morning came, the plumes had been measured overnight, and as morning came, it was clear that it was a fortunate result. The plume was contained within a fairly narrow volume and swept out over Lake Ontario. It was the largest peacetime evacuation of a civilian population to that point. And there were no first responders hurt in this, fortunately. This shows a measure of the consequences of that derailment. What about Helsinki, and what about our urban centers in Europe? Wouldn't it be valuable if we had knowledge before an accident of the vapors present around an urban center and the growing abundance of a potentially dangerous substance in a neighborhood from a gas leak, from an industrial leak? This is the vision of GIDPROVIS. Our radical idea is to build technologies that permit human beings to see the invisible, for human beings to look out over a room, a city block, a neighborhood, maybe even an entire city, and see what the vapor composition of volatile organic compounds is. we need to develop these technologies. They do not exist. And so our funding and our efforts are to build those technologies and deliver them to those who might find them useful in their work. So how do we go about making the invisible visible? Here's a scene of urban reclamation on the top right, and on the bottom left is an individual who has glasses, and in the glasses he's able to see the vapor emissions coming from the soil, from a nearby freeway, and from a building in front of him. How to do this? We've identified a path of science and technology to develop, and this includes separation of constituents in the air, identification of the constituents, extensive data processing in a data hub and display of the images of the vapors, and then finally, the human reactions to these vapors. How should humans react with the knowledge of the vapors that they're seeing in front of them? As I said, these technologies don't exist. They'll be the subject of research and development over the next 3 years. We have hopes that we can make these useful to first responders in the future. Our community, this is not done by 1 or 2 individuals. This is done by a community of researchers, engineers, scientists, human response researchers. We're a European consortium in locations shown here. And I'd like to draw your attention to the top center, human response researchers. Once we have the chemistry, physics, electronics, and engineering and computational processing done, in a sense, that's the easy part. The hard part is how to communicate that in a usable way to those who need to know. And so we're also looking at technology with a human dimension. How do you respond to knowing that styrene is present at 50 part per billion, 10 meters from you? Do you run? Do you put on a gas mask? What do you do? How is it best that that information is delivered to you? Visually, with sound, with information, how to deliver knowledge about the invisible world to you. And then finally, once we have the technology in place, making molecular augmented reality something usable for you is, of course, a goal or a wish from this project. So we're interested in teaming with those in the first responder communities to help us understand how these technologies could be useful for them and how we configure and organize the information flow. If you're interested in working with us at the University of Helsinki, I'd invite you to visit our web pages for regular updates on the project. Can I start again?
Yeah.
If you're interested in contributing to what we hope is future technology for first responders, I'd invite you to visit our webpage for regular updates, contact our project director, Professor Paula Vannanen at University of Helsinki. We would be very interested in having you work with us. Thank you.